In this video, we are going to see how to calculate properties, how to make a selection, and use this selection to derive a new property. We will then see how to import and export data, and finally how to save everything in a workspace file. We are going to use the dataset with an aspirin molecule in interaction with the phospholipase protein that is available on the wiki of VIAMD and also in the link in the description. I have now loaded the GRO file and the XTC file, and VIAMD has created automatic representation for the protein, the ions, the ligands, which is here the aspirin molecule, and water, which is not shown by default. And for the moment, I will not display the ions and focus solely on the molecule, aspirin, which is res name AIN, and on the protein. So this trajectory shows the molecule leaving the pocket, and first I want to show you how one can use the shift button and left click to make a selection in my molecule. So I'm going to start by selecting two atoms. Then when I right click on this selection and I go to script, I can see that I can calculate the distance between these two atoms. You see that it is expressed in different ways using the VIAMD language, but all expression will obviously produce the same property. So I'm going to choose the first one and also clean the example script that is present when you open VIAMD. If I select the third atom and do a right click, then this time VIAMD is going to suggest different ways to calculate an angle or to save those atoms as a selection. We're going to choose one of them so it will appear in the script editor. Naturally, if I select the fourth atom, VIAMD is going to suggest to calculate a dihedral angle. When this is done, I can unselect everything by pressing Shift and clicking outside my selection. Now we are going to evaluate those three properties, and we can then visualize them in the timeline window, and I can of course plot those three parameters here. Now we are going to define a pocket for the aspirin molecule, and to do so I will first select my molecule. And you can see that right now I can select atom per atom using Shift and left click. And this is because the granularity of my selection is defined at the atom level. I can change the granularity to residue, and then if I hover onto a molecule and use the Shift and left click, I will select automatically the full residue. So now that it is selected, I'm gonna place it back in the pocket right at the beginning of the trajectory, and I'm going to grow the selection. And to do so, I will do a right click, and I'm going to selection and then grow. Then I'm going to switch from covalent to radius, and I just use the slider like this, but I can also use Control plus left click to enter the desired value and then apply to select. My selection here contains the pocket and the aspirin, so I can remove the aspirin by using Shift plus right click on the molecule, and my selection then only contains the pocket. I can then do a right click and click on this selection so it will appear in the script editor. Then I can rename this selection to pocket, and I can use this pocket as a filter to create a new representation. I will change the type for licorice and the coloring for residx so we can better distinguish the different residue in the pockets, as you can see when I remove all the selection. So now that the pocket is defined in my script, I can use it to derive new properties. So I'm going to start by defining d1 as equal to the distance between the pocket and the res name AIN. Then I can evaluate pressing the button or using Shift Enter. And I'm going to remove those properties here, and I'm just going to display the distance here, dist1. I can have visual feedback for all the parameters I have calculated so far. For instance, here you can see dist1, the distance. You can have the feedback for the angle and for the dihedral angle, as well as for the pocket. So for D1, I'm using the distance function and I'm calculating the distance between the pocket and the res name AIN. And the distance function by default takes the center of mass of the two units that you are considering, as you can see in the visual feedback. So instead of the distance function, I can use the distance pair function to evaluate the distance between the pocket and the aspirin. And I can plot them together like that. And if we look in detail at D2, we see that this is of dimension 200, and we can understand that this is the distance between the center of mass of the 10 residues of the pocket and the 20 atoms of the aspirin. If I'm now interested in the distance pair between the center of mass of each residue of the pocket and the center of mass of the aspirin, I can use the center of mass function on the aspirin molecule. I'm going to remove D1 and D2 from the timeline, and before plotting D3, we are going to confirm using visual feedback that now D3 is of dimension 10 and that it corresponds to what we wanted. For D3, you can either plot all the distances, but you can also choose to plot the mean, as well as the variance and the min-max. VIAMD allows you to import file in the script editor using the import function. And you can import ASCII file such as CSV and XVG, but also Gromacs Energy file, EDR. So here my energy file is in the same folder as my GRO file and XTC file. And when I hover on the expression, I can see all the terms that are included in my EDR file and choose the one I'm interested in. I'm going to focus on the Coulombic interaction between the molecule and the protein, as well as the Lennard-Jones interaction, which are respectively 68 and 69. So I just need to enter the flag 68, and the visual feedback here confirms that this is the Coulombic interaction between the protein and the aspirin, and I will accordingly rename my property from LG to cool. And now for LJ interaction, I can do the same thing with the appropriate flag. And finally, I can add those contributions in the following way. I can then plot this new property in my timeline. All the parameters that are evaluated in the script editor can be exported by clicking on File and then Export. In data type, you can choose temporal and then the different properties that you have evaluated. You can export as XVG or CSV. And as for temporal data type, you can also export distribution as XVG or CSV. Let's have a quick look at the distribution window that is very similar to the timeline. You can drag and drop properties and use different subplots. So here I just show you how you can combine different windows, which is a functionality of ImGUI that we are using in VIAMD. And this feature becomes very useful when you have a lot of windows open. The last thing that you might want to do after spending time defining all your representation and properties for your system is to save your workspace so you don't have to redo all those operations again. So to do that, you can click on File and Save Workspace, and then we recommend to save it in the same folder where you have your trajectory. And we will use the extension .via. When you look at this file, you can see that several information is saved, such as the path of the GRO and the trajectory with respect to your VIA file. It is followed by information about the animation, rendering style, and camera position. Then there is a description of the different representation, and finally the content of the script editor. So you can obviously edit this file with any text editor. To open a workspace, you can click on Load and open Workspace, and all your representation and content of the script editor will appear, and you can just evaluate again.